Hello, I'm Alistair Foreman. I'm here with Max Budendijk today. He's the product manager for Aquarius Samples. Together, we'd like to showcase the functionality of Aquarius Samples, and we'll reference some real-life applications of the system along the way and show you how it can help improve your efficiency. We'll start with an overview of the system, and then we'll look at, I think in this case, a real-life example of some contamination of metals in the Washington, D.C. area. So, Max, could you kick things off and give us a quick overview of Aquarius Samples?
Thanks, Alistair, for the introduction, and yes, I'll jump right into it then. On the screen right now, we can already see the homepage of Aquarius Samples, and it's illustrating the main workflow and the key process steps along the way. First, we got the management of your sampling locations with spatial information about where they're located, standards that might be applicable, attachments could be detailing the location itself, pictures, something about access, and similar things. We got field trips, which are mostly an organizational item to plan and track who is going where and when, which gear and equipment to bring. And we got the field visits, which describe then the actual planned and also the completed field work. Furthermore, we got the two main data streams, which are the in situ field data, everything you can measure right there and then. And we got the ex situ data, which will require samples and specimens to be collected, be sent to a laboratory for analysis, lab reports to come back, and then both will end up eventually as observations, which will then be available for your analysis and investigation.
Cool, that's pretty clear. Thanks, Max. We'll get to that example I was talking about. So one thing we often hear from customers is that they find it really challenging to work with their existing data. They find it hard to find, they don't know where to look, there might be multiple copies, and they're not quite sure which version to use for what purpose. It can be pretty hard for them. So let's look at our example. Maybe we did a study about contaminants in a watershed in the DC area, metals, let's say, and I need to review that data. Max, you want to show us how that would work?
Sure. Let me show you how easy it is to bring up just that data within samples and to review it. So I can actually use this interactive workflow diagram to navigate to where I want to. In this case, we're looking for observations, so I'll just use this one here to navigate to my main window of all the observations, all the data within your system. And think of it similar as a search engine. I can specify any sort of filter criteria up here and always get instant feedback on the data set that matches that. Right now it shows me all the data. And yeah, now let's get into it. But what next? Not sure about you, but I'm pretty bad at remembering things. So all we said is the data is in DC. So maybe I'll just try asking the system for that. I'll enter DC right here, and then let's move to the map. And yeah, right there, now I remember these are the three locations where we loaded some demo data within the system. And I can use this map to get a really quick overview of how my data is distributed, which locations I have, how much data I have for what location. So let's look into this one, Chisenko Bay. We can see we got a couple of hundred observations right there. I have links on the side here I can actually use to navigate to that data right from here. I got access to the visits, the latest visit, some spatial information about where this location is located. And yeah, this type of instant feedback really helps me to speed up this data discovery process. But let's drill down a little bit further. I'm going to go back to my list of all my observations. And now I'm going to filter the locations that I just found using the map. Those three, because I know that's where my data for this example will be. So next I'm going to set my sample medium filter to water. We're looking at some water data here. Yeah, please have a look at these all other sample mediums within this filter. The system is able to store a lot more data than just water data, but we'll look into that in subsequent videos. And by the way, I'm just going to save this query I've typed into here as a bookmark, so I can use this for other examples later, or I could share this with some colleagues. Since within your organization, it's probably going to happen very often, you want to look at the same data, and you can use these links. They actually include the filter criteria, can send them around, and everybody can be looking at the same data set. So it's very handy. Or you can just save them for yourself for convenience. And please note, as I'm adding filters, the filters I've selected now have a little blue shade around them, so I can see what's selected. I can see the value that's selected. The number up here counts how many filters are selected, so I always keep track of the filter criteria I'm using, and the number of matches is subsequently going down as I'm narrowing down to my target data set by applying more and more filters. Let's continue with the example. We said we're going to be looking at some metals data. So I'm going to pick my analytical group metals right here. And in fact, for this example, we said we want to be looking at observed property copper and lead in particular. So I'm going to type copper and I'm going to use lead. And by the way, these type ahead text searches are really, really handy for large data sets. If you have like hundreds and thousands of parameters or locations, this way of narrowing down to what you're looking for really makes life easy, since you don't have to scroll through massive long lists. So now we've found the two parameters or observed properties we're looking for. And you might all know that for data like copper and lead, there's lots of different analysis methods you could be using. Different ones are being discovered or applied over time. And the results are quite different. They differ in terms of precision, detection limits, and of course things like price. But maybe for this project, so we want to be looking at only a specific subset of these methods. So again, I can filter only the analysis methods I want to use. Maybe in this case, I want to use these two, and my set of data will be adjusting further.
Hey, Max, that's pretty cool. I'm curious. There's a lot of typing and filtering going on here. How does that actually work behind the scenes?
Yeah, good question. That's an interesting fact. So there's actually a whole set of search servers that are being used in the background. And what they do is they basically run an indexed full text search across all the fields in the entire data set. So what is that good for? You may be wondering. Even heavy usage of this by many users on big data sets, it won't constrain the performance of your operational database. And this is really a big advantage over classic and query-based systems.
Oh, okay, thanks. That makes sense. Sorry for the interruption. I guess we'll talk more about system architecture in a future video. So why don't you, carry on with your example?
Sure. Yeah, continuing with this project, we might be interested only in looking at reviewed data, meaning my initial QA and QC has been done. So I'm going to use the status filter to filter to data that has been marked as reviewed already. And maybe we're also interested in only using a specific sample fraction. So I'm going to filter it to total results right here. And again, you can watch the number of matches immediately adjust to the filter criteria I've just added. So let me bring up this data set after we are done filtering. Let me bring this up in a chart. That's all I have to do. Click the chart right there. And yeah, it's quite obvious that from just looking at this chart, there's something going on at this location, Shizenko Bay. We got some elevated levels of copper and lead compared to the other two locations.
Huh. So right now, I probably want to just get the data out. Is there an easy way to do that?
Yeah, there is. So we got a lot of export options right here from this list. So I can either do an export to CSV, like a flat file. I can do a crosstab to actually look at this data in more like a visually appealing way. Or I can also export this to the EPA's WQX format. But for this one, let's do a crosstab of this data right now, since that's a good example for this data. So I'm going to bring this up in Excel. If in case you haven't noticed, it's just going to download a file into your browser right here. So I'm going to open this up and I'm going to use Excel just for a quick way of visualizing this data. And just for the sake of making it a bit more easy to look at this data on a small screen, I'm going to do a few real quick formatting options. So within this data set, we can already see here's our copper data. And right over there, we have our lead results. And by the way, this is just Excel's funny way of displaying scientific, like small numbers. So within this file, we have our different locations, timestamps, the different samples, the different bottles, and the different results and analysis methods. Here's data about non-detects, and we can even see here's exceedances within this crosstab. So this is a really quick and powerful way of narrowing down a very complex data set and then getting a quick visual representation of what's going on, different samples across different sites, including things like non-detects and exceedances.
Thanks, Max. Now, before we go on, can you spend a little bit of time looking at some of these terms and observations and so on, and concepts that we've seen so far?
Yeah, good idea. So some of you may have wondered, in fact, what are these terms? What is an observation? What's an observed property? How did we come up with these? So this terminology is specific to the observations and measurements model defined by the OGC, the Open Geospatial Consortium. And we chose to base Aquarius samples on it because it's a science-driven model, which, by the way, is getting adopted more and more. For instance, the Bureau of Meteorology in Australia, the BOM, they just released a national industry guideline for water quality metadata. And this is based on the same data model. And as a result, the Aquarius sample and this industry guideline are pretty much the same thing, since they're both based on that standardized data model.
So can you give an example of why this is important, how it helps someone managing a system?
Yeah, most of this metadata is tracked as attributes on individual results. And the key data types are fully built into the system. So one example could be lab and field data. It's something that's built into the system. Or that could be an example of field and lab-based pH data. It's right there. You don't have to really configure it. The system already knows those things. Or similarly, specific metadata and attributes such as a sample fraction, which we have here, the filter, will automatically only apply to observed properties that are chemical. So that further ensures your data quality. And you may be wondering, why is that important? How does that help anyone? By having this data model, this really reduces the effort for data managers to keep their data quality up high, since the metadata such as analysis methods, detection limits, these sort of things, they will change over time. But this is built into the model, so you can track your observed properties like copper and lead, and then per result, the individual metadata, that can change over time, but this is handled by the model. The model supports that. So this is really reducing my long-term efforts of housekeeping of available metadata for my results.
So thanks, Max. But that actually reminds me of a related topic. We hear from customers often that it's really difficult to integrate all of their different types of discrete data from the sampling programs that they conduct. So for example, some projects involve vertical profiles, lab chemistry data, taxonomic data, biological results, physical field measurements, and often these are all in separate systems. With Aquarius samples, it's all in one place. Is that right?
Yeah, absolutely. So as you said, those data types, in fact, are quite different. So historically, what happened with those, they started living in different places. Some might be in spreadsheets, others might be in Access database, as you said. Yeah, but also there's more and more needs to combine those and actually use it together in integrated analysis. So if you're the one that's tasked to combine, integrate all those different sources into one piece, wow, you're in for a real treat. So that's why we're here to show you today how Aquarius sample is going to help you with that. It's really designed to be your one single source of truth for the different data types, all those different types of results, and the resulting or the related metadata about those results. So to illustrate that and help you all get started a bit easier, we put an overview graphic into our online help. The online help is accessible right here. By the way, it is context sensitive. So depending on where you are within the application, it will always bring up the content that is most relevant to what you're doing right there and then. But speaking about the overview, so within here, we have a handy little graphic about the key entities within Aquarius samples. I'm just going to bring this up. So we've looked at some of it at the key workflow already. We have our field data right here. We have trips, which include a bunch of visits to different locations. Sampling locations right here. There could be different standards and guidelines that apply to those. Within each field visit, we have different types of data that's being produced. There's routine samples and specimens being taken. We have field surveys related to taxonomic data, and we have vertical profiling data. Some of that data will require analysis within the lab, where different entities such as shipping containers, lab reports, or laboratories come into play. And then all of those in the end will produce observations of different types, such as field results, lab results, related QC results, and biological results. But all of those observations are available for you.
And we can export directly to WQX2, right?
Correct. It's right there. One click. Here's your WQX export.
Thanks, Max. So that concludes our first video on Aquarius samples, where we gave you an overview. In the next video, we'll look at some chloride sampling and a few other examples. See you then.
See you.